So it's me again. Oh, I get to introduce myself 2 times today, and I'll do it because we're recording. So, yeah. Well, this talk is about infrastructure as a service beyond infrastructure. Although the title on the schedule says cloud as a service beyond the infrastructure, which is very accurate as well. We'll talk a little bit what's there beyond infrastructure, what services there are or there should be in a cloud provider to be like good for you, good for like your applications and the things you want to put in there, and why shouldn't we limit ourselves to just infrastructure as a service? Like, well, there was like a huge boom of infrastructure as a service, starting a couple of years ago, even when OpenStack started, and many people stay there with that concept, and I believe that there's more beyond that. And like normal disclaimers, like I said before, I speak really fast. I tend to speak really fast. I rant a lot, and this talk will have a lot of ranting. Be aware of that. And that's pretty much it. I said bad words. Again, don't take it on me. It's not against you. It's just like I get real excited when I start talking about things that I rant about. This is me again. Questions, whenever you want, just raise your hand. I'm happy to be interrupted. I don't mind. Thank you all for being here. That's my Twitter handler. That's my email address. If you have feedback about this talk, please email me. Either it's good or bad, I don't mind. I actually appreciate a lot of the feedback. And I work at Red Hat. I work at the RDO team, which is the team that makes sure OpenStack works perfectly in every single Red Hat-based distribution. That includes Fedora, CentOS, and Red Hat Enterprise Linux as well. And I take care of the storage side if you're interested. But let's get to the topic. First of all, what's cloud? I tweeted like 2 days ago. I gave the same talk in another conference, and I tweeted like, if you want to know what a cloud is, just come here. And someone replied to me saying, well, a cloud is a whole bunch of water drops put together and condensed, and that's a cloud. And that's a very good definition about cloud. But in our industry, cloud means something completely different. And many people have given definitions of what cloud is, and we have one of them in Wikipedia. And honestly, I couldn't disagree more with this. I don't believe that's a good definition of what cloud is, and I'll explain why, and I will propose a new definition at the very end. And before you tell me that I should go to Wikipedia and contribute back, I already did it. And it turns out that contributing to Wikipedia is actually harder than contributing to OpenStack. And I really don't care that much to waste my time there, honestly. Like, I sent my request, they replied to me that I should start a new like discussion forum and I don't know what, and talk to some other people and get some consensus, and I said like, you know what, I don't care. You stay with that and I'll just go and give this talk everywhere, and I'll make sure people understand what I mean about cloud and what's there in a cloud provider that goes beyond infrastructure. But before we start on what I consider there should be in every cloud provider, let's just go through the theory first. Like, how many of you know what infrastructure as a service is? Just 3, 4, okay. Platform as a service. Software as a service. I expect you all to keep your hands up. Okay, good. So I'll do, since not many of you raise their hands, and I like to ignore the audience when I ask these questions, I'll just keep explaining what it is. Infrastructure as a service is the lowest level of your whole infrastructure. That's your hardware. That's your storage. That's everything that's tangible that you want to make available for people to consume. So when you say you have infrastructure as a service, it's because you're making all those like computing units and storage units available for people to consume them. So they will say, I want a virtual machine, I want a bare metal unit, or I want some space in your distributed storage so I can use it and I can like consume it as a normal user. So that's infrastructure as a service. And on top of that, you can put a platform as a service. And platform as a service means that you don't care about the infrastructure, you just care about what you're going to install there. But platform as a service makes you services available for you to create your infrastructure as you like it to be. So say you have your application, and this application you want to deploy it somewhere. And just to give you an example, Heroku is a platform as a service. OpenShift is platform as a service. So you basically go there and say, create a new application for me, and I want to deploy my stuff there, so I'm going to upload my code there. I'm going to run it. But for my code to run properly, I need these services to be available for me. So you say, I want to add to that platform, I want to add a Redis instance, and I want to add a MongoDB instance, and I also want to have an Nginx running. And then you just configure that. You just click buttons. And if you like CLIs, you can just run CLIs commands. But you don't have to configure it yourself. The platform will do that for you. They will take care of all that. You will only receive a URL that you have to use. If you want a database, you'll get a database access URL. If you want a Redis instance, you will get the Redis URL. So you can just talk to it. You don't need to configure it. You don't need to maintain it. You don't need to install it. So that's platform as a service. It makes the platform available for you. Then we have storage as a service. And storage as a service is basically, it goes above the platform. And you don't have to, in the software as a service, you don't have to take care of the platform. You don't have to install everything. You just have a software that you want to use. You want an instance of that software for you. For example, WordPress, that's software as a service. When you go to the public service, or the WordPress public service, and you say, I want to create my own blog, and you say, create a new blog for me, and then you get the URL of your blog, and you just go there to the admin panel, configure everything, set it up, and start writing posts. So that's software as a service. You have a software that makes itself available for you, and you just have to click some buttons, and it will create a new instance of that software for you that you can just consume. And then we also have cloud as a service. Oh, well, there's a star there, like containers as a service as well. But we're talking about cloud in this case. Cloud as a service is basically all these softwares put together and made available for you. So you have infrastructure, but you also have platform, but you also have software as a service. And depending on your needs, you will consume each one of them, and you will use them as much as you need them. Just parentheses, like every term in our industry, they are all overloaded. And so the same happens in the cloud. Like you have cloud as a service, but you also have containers as a service. You have software as a service, but turns out that also means storage as a service. So let's get this clear. We're talking about just the services on top of all the infrastructure that are made available for you. And just a little bit of more theory here, 101 on distributed systems. What is a distributed system? A distributed system, like it says there, like the multiple offering connected computing units that just work together. That basically means you have a whole bunch of servers put together and they work. But that doesn't mean they are in the cloud, they're just distributed, right? There might be right there next to you under your desk. Taking those to the cloud doesn't just mean getting them out of your place because you can build a cloud in-house. What it means is that you need to have some extra guarantees to consider that being a cloud. For example, you might want to have auto-scaling so that your service can scale automatically based on your needs, based on how many users you have and how many services are running on top of it. So having a distributed system does not mean being on the cloud or being cloud available, so to speak. You need to have some extra guarantees for that to work that way. And for every system you develop, chances are that you will use at least one of these. And please read the, well, you are not available to read that. So what that says, like the really small letters, it says that this is not based in any empirical research because I just made that phrase up, literally. But turns out it's true. Every time you want to create a new service and you want to run it, you will need at least one of these services, or two, I may say. Because computing nodes and storage nodes are basically always needed. So chances are that you will need always compute and other kind of services. Like firewalls. So how many of you are sysadmins here? DevOps. Just one. So we can just talk about DevOps here. Developers. Good. That's my crowd. So if you have ever configured a firewall, you know how hard it is to do that. And how many times I've kicked myself out of my server because I just set up the wrong rule. And turns out this SSH fell, and I had to reboot the whole thing or create a new server from scratch. And since firewalls are really hard to configure, why would I ever want to do that myself? If I'm using a cloud provider, and firewalls are so important for cloud applications, why wouldn't my cloud provider just provide that for me, right? So I just want to get an interface or a CLI that is very user-friendly that I can just use to create my rules. And I'll say like, you know what, create a new service for me, a new server for me, a new instance. And please apply these rules to that. Or to this set of instances, or to this complete subnet, I just want this kind of traffic to go through. And the rest just drop it. And I want that to be easy because I want to focus on my application. That's why I'm using a cloud provider. Otherwise, I would just set up everything myself. And I would just hire a whole bunch of people that would do that themselves. So firewalls are really important, are hard to configure. And again, like cloud providers should make it easier for you to do that. And before I go any further with the talk, let me say, like, this is not targeted to any cloud provider specifically. Like, I work on OpenStack. Many of these things exist in OpenStack already. Some of them don't. But the same things exist in AWS, if you're familiar with it, like Amazon Web Services, and some of them don't. So this is not targeted to any specific cloud provider, but this is just what I consider cloud providers should have. Then we have balancers. If you're developing an application and you want your freaking application to scale because you want to go big and you have your really amazing startup, or you're expecting your company to grow and you're expecting to have a lot of users, you need to balance your application. Like your API nodes, all your secret nodes that are bound to a private IP address that you want to make reliable, and you want to expand them on more servers. You need to balance them. You need to put something on top of it that you can use a single URL, a single address that will scale everything through your nodes, right? In our case, so not many of you are familiar with OpenStack here. So in OpenStack, we have every service is split in several smaller services. And every service has, or most of them have, a API instance that we would just deploy as a user-facing node that you want to have in your application, in your infrastructure. So you need to balance that. You won't just deploy one, because if you deploy one, it will be hit by every single user, and it will likely die. If you want to go big, you have to have balancers. So why you would ever configure a balancer yourself? If you want to configure the balancer yourself, it means that you need an instance for that, because you have to install it. You have to have an instance, or probably more than one, because if your balancer goes down, all your instances will be unreachable by the end user. So you need to have an instance for that. So why would you ever install a single instance to install your balancer that you will then route all your traffic to your endpoints in your infrastructure? So again, like cloud providers should give that for you. They should make it simpler for you to say, you know what? I want 1,000 instances deployed right now, like that. 10 seconds, because I need them. I need to auto-scale. I need to elastically scale my infrastructure because my users are coming here. Like I'm getting big and my whole thing is growing. And I need to scale very fast. And I don't want to configure my freaking balancer myself. I just want you to do it. And I'll tell you where my instances are. And actually, you're supposed to know where my instances are because I just told you to create them. And the cloud providers should just configure the balancer just to distribute the traffic across all your instances. And then we have messages. Who knows what a simple queue service is from AWS? Simple notification service. Just one hand. Good. So RabbitMQ. Come on. There you go. That's better. So if you want to go big, if you want to grow, if you have an application that you want to scale properly, you're likely going to have a message broker deployed in your infrastructure. And if you have ever deployed RabbitMQ or a messaging service, you know it is really hard to scale it. It might be simple to deploy it. It might be very simple to just say, like, install RabbitMQ and run it, and then you put a balancer on it or whatever you want to put on it. But scaling brokers, that's hard. And the reason it is hard is because they have to give you some guarantees that when you scale them, it is really hard to provide them, like message delivery, like message replication, and the fact that you won't ever lose a message again. And since messages are really, really important for us in a distributed system, I believe cloud providers should give that for you. And in fact, AWS does that, and OpenStack does that as well. Like we have services that are supposed to be very simple to configure so that you can get a queue where you're going to put all your messages, and then you will have some consumers getting those messages out of it. Why would you want to configure RabbitMQ yourself if you just want a single queue or a couple of them, or you just want to make them available for your users? Like this is the whole point about having a cloud provider, and I'm not saying a cloud infrastructure, I'm saying a cloud provider, is to simplify your life. You just want to go live. You don't want to have any delays between your application and your get-go time. You just want to deploy it, run it, and have your users consuming your application. DNS. So, say you want to auto-scale your application. Say you want to expand everything because you want to grow. And then you go from 10 instances to 1,000 instances. I'm pretty sure you don't want to learn every single IP address. I'm pretty sure you want to have an easy way to reach those instances that is predictable, intuitive, and that you know the format, right? And the easiest way to do that is by having a DNS. But turns out that not all cloud providers give you a DNS as a service. Some providers just say, okay, you want compute instances? There you go. Just launch your instances and then configure yourself your DNS. And turns out you have to install a DNS for your infrastructure. You have to maintain it, create all your URLs, sub-URLs, and everything. But every time you launch a new instance, you have to update your DNS. It'll take time. You have to manually do it, or you have to have your Puppet scripts or manifests and Chef scripts and everything that will do that for you. And it takes time. And if you want 1,000 instances, it takes even more time. So you want it to be simpler. You want the cloud provider to know that you just launched 1,000 instances and that the same pattern you've been following so far, you want to keep using it for the rest of the instances. So you will call it like instance 1, instance 2, instance 3. You don't necessarily need to learn the IP address. You just know, you just need to keep your own mapping of what those instances are supposed to be doing. And then you just know that each address from the 1 to the 10th are going to point to those instances, or the 1,000th probably. So again, DNS, this is basic. You need it. If you want to grow, if you want to scale or auto-scale even better, you need a way to reach your instances easily. So you need a DNS, and you don't want to maintain it because it takes a lot of time. It is extra work that you probably don't want to do, and you need more resources to that. But that's not all. Databases. This is probably a more like a complete different example from what I've been talking so far. Like so far I've been talking about things that are like more infrastructure oriented, more security oriented, more how to say, scaling oriented. But in this case, you want a database. You want a place where you can store data. You want a place where you can just say, you know what, I don't care what database you're using. I don't care how you're managing it. I just want a freaking URL where I can just put my data in and take it out when I need it. And I want this database to have these properties. I want it to, I don't know, be a relational database or a no relational database, or I want a caching system, that kind of things. So you want that to be simple. You want just a button that you can click and say, like, you know what, give me a MySQL instance like that. I don't want to install it myself for several reasons. Either it is your production environment, your development environment, your testing environment. It doesn't matter. You can be playing with it, but you want it to be simple because you don't want to install it yourself. So again, you have this in AWS, you have this in OpenStack. But again, not all services give that to you, and you should ask for it. This is platform, remember? Heroku. I don't want to take care of my databases, I just want you to give that to me. The same thing does OpenShift for you. It's very simple. You just ask for it and you'll get it. But there's like if there's a point where you need to take care of it, like there are cases where the deployed database in the cloud provider is not good enough for you. Maybe some settings, configuration parameters, some things that you want to tune up, and that's fine. It's perfectly fine to reach a point where you have to maintain it yourself. And we'll talk a little bit more about that. Authentication. There's so many implementations of authentication systems. It is so hard to implement authentication. Why would you ever do it yourself? Like, there are many different ways. Like, there's OAuth, there's token-based, there's basic HTTP, there are a whole bunch of other ways to authenticate. You can use LDAP, Kerberos, wherever you need. And there are services that do that for you. I've seen so many services reinventing authentication and just like, you know what, I'm going to create my user model and I'll put a password field in there and I'll just store the password in plain text because no one cares about your password, right? And then they will just store it in the database and then they will also mail you the password, obviously, because they have to. And then they'll say like, okay, turns out I want to have my mobile application. And I don't want you to input your password in your phone, so I'll give you a token-based authentication. And I'll reinvent it because I have time to waste. But turns out that there are so many services that do this for you that you don't have to do it. Like weird stuff in OpenStack, you have Keystone. Keystone does that perfectly for you. There's very smart people working on that. There's people that take care of security issues, token expiration, encryption, password keeping, and all that kind of things that you don't have to worry about it. You just have to consume the service. You might not want to consume that single service, but you can also, I don't know, using Google Auth, Twitter Auth, whatever you want to use. But there's so many different implementations of authentication that it is not necessary to create it again. So if you're a cloud provider or well, mostly cloud provider, but there are other services that provide authentication for you that you can just install it and consume it. Do it. Do it because you don't need to take care of that yourself. Like Keystone itself has support for Kerberos. It has support for LDAP. Like you can just install the plugin, configure everything, and you have all your users that you have in LDAP, and you have them available in Keystone right away. It has roles, passwords, users, services, endpoints, and a whole bunch of other things that you can use. So again, look for it. There are many implementations of authentication services, and you don't need to reinvent them all. So after all this, the conclusion is like, don't be fooled. If you have a cloud provider that is just giving you computing and storage, that's a virtual private service. There's no difference between having a lean node instance where you just have computing and storage and having a cloud provider that just gives you a way to create a new instance with a fancy CLI tool, and it allows you to store your data in it. Again, there is way more beyond infrastructure to a cloud provider that you should be taking care of. There are many other things that will make your life simpler, and that there's people working on that to make your life simpler, and that you should take care of those things. But let's not stop there. Like, let's not stop on what will help you deploy your application and having more users. Because having a big application or even a small one is it's way more than just deploying it. It's maintaining it. That's the hard part. Once you deploy your application, which might be very simple to install or very hard to install, the real deal is maintaining it up. Like keeping your instance running, keeping all your nodes aligned, synced, keeping your database alive, keeping your cache system alive. And you have to monitor everything. You need a way to monitor every single instance. You need a way to just say, hey, my nodes are stressed. I need to expand my system right now. If you don't have a way to do that, well, the chances are that your whole system will crash very soon because you need a way to be alert. You need a way to get notifications out of your cloud provider when your instances are dying because there's a bug in your application. Or you need a way to, your cloud provider to tell you, hey, you're running out of space. You might want to add more disks or expand your nodes or that kind of things. So cloud providers, I really believe cloud providers should expand themselves to way more than just having a nice way for you to deploy applications. What about orchestration? So you have 10 instances, and you want to go from 10 to 1,000. Do you really want to install every single one of them? It is really easy to, these cloud providers give you a nice way to just create a snapshot and then boot your instances out of that snapshot. But is that what you really want to do? What if you have a template? And in that template you say, I want a Red Hat Enterprise Linux instance running, and I want these applications to be running there. And without going there and creating the instance and installing the things yourself, you just give that template to your system and say, you know what, take this template here, multiply it by 1,000, and just run it. And having an orchestration system that will do that for you. And it's just not nice because it allows you to scale very quickly. It is nice because it is a backup for you if your system goes down. If something happens and you have to recreate all those instances yourself, you will suffer. So if you have a template like this and you say, like, this is what my infrastructure looks like, and it will always look like this. Like, think about your Puppet manifest. You just have a manifest that describes how your applications need to be installed in your server. Well, it's the same thing, but for your infrastructure. You just have a template with everything described there, and you tell your cloud provider, hey, this is what my infrastructure should look like. So you just go and do it. Don't waste time. I need this thing. But then you say, can someone else just do it for me? Like, if I have a cloud provider and it took me like 2 months to figure it out, and to, you know, like, go through the contracts and sign it, and it's so freaking expensive, why would I ever move away from it? Just because it doesn't have database as a service? Just because it doesn't have DNS as a service? Well, it turns out that someone else can actually do it. You don't have to depend on a single cloud provider. You can also depend on multiple cloud providers. You can also depend on your in-house cloud. You just don't want, you don't have to just deploy everything in a single place. You can have all your API nodes running on AWS and then having your database in-house because you know the privacy rule, whatever, in Europe, and you don't want your data to be outside Europe. And then you say, okay, since I have sensible data and I want to have it in-house, I'll hire people that will maintain this thing, and I will use, like, all my databases are going to be installed here, and then you can just access those databases from outside, which is perfectly fine. You just set up a VPN and then you configure everything, and you're good to go. And that's what is called hybrid cloud. It's a way to just mix private clouds with public clouds all together. Like, you just have to have a single cloud provider. You can have several of them. Just make sure you don't run out of money. And this takes me to the next and probably final point of my whole presentation, and it is cloud interoperability. And this is something that definitely not all cloud providers give you, and not many of them take care of it, but we do a lot in OpenStack. And the reason why we do that is because it is really important for us, for you to be able to use multiple cloud providers without having to rewrite a single line of code in your applications. So, say you have your application deployed somewhere, I don't know, AWS, and you're using EBS, which is the block as a service service in AWS. And then you want to migrate your applications from there to Rackspace, which is using OpenStack. Rackspace runs on OpenStack, or runs OpenStack, actually. Then in that case, you will have to rewrite a lot of things because AWS API is not compatible with OpenStack's. And that means there's no interoperability between those clouds. So for us, it is really important that if you're using HP Cloud, which also runs OpenStack, and you want to move to a Rackspace, you can do that without changing a single line of code because the APIs will all be the same. So we don't allow, in OpenStack, we don't allow things like, if you enable this configuration option, you will have that endpoint available. No, the API has to be the same. If you want to be vendor locked in, that's not a problem. There's a very detailed specification on what APIs and what endpoints have to be available for the users for your cloud to be considered OpenStack branded, so to speak. There's no OpenStack brand, but let's just to have the OpenStack stamp on it. And if you want to add more endpoints, that's fine. That's not our problem. That's your problem. But if your users are actually using that endpoint and they want to migrate from your cloud to another cloud, or just use several clouds at the same time, they will have some issues because the clouds are not interoperable. And that's the whole point. If you want to deploy OpenStack internally in-house because you don't want to take those services outside for various reasons, it is really important for you to be able to do that without changing a single line of code. So cloud providers should be interoperable. And we take care about that much that we even have support for AWS's APIs. Like, if you want to start a new instance in Nova using Boto, which is the AWS library, You can do it. You just point to the Nova API and just tell it using the AWS API, hey, please start up a new instance for me, and it will do it for you. So that's how much we care about cloud interpretability, that we even have support for the AWS API in OpenStack. And again, hybrid clouds. I'm not going to say that's the final feature, but you definitely have to have it in mind. You have to consider a way to just deploy things in the places where it's more convenient for you, and in a way that is convenient for you, and that also provides you reliability and gives you the safety guarantees that you need for your application to scale, to be backed up, and to be restored in no time, because you don't want to have any downtime. So if something goes wrong, you need to be able to just spawn out everything, just like that, in 1 second. And as I promised, this is a definition of cloud that I fit into Wikipedia and they ignored me. It might not be right, correct, but it just goes a little bit closer to what we just talked today. And if you think that's not good enough, well, please email me what you think is a perfect definition for a cloud. But like I said, I'm not here to tell you exactly what the cloud word means, but I'm here to tell you what a cloud provider should have for you to even consider it useful for your services and your applications. So, what do you need? Well, this is, I'll use the best excuse we have in our industry, guys. It depends on the context. If you want to have a database as a service, well, you'll pick your cloud based on that. If you need DNSs, well, you pick your cloud based on that. If you want to have balancers and all that, again, you will pick your cloud based on that. But remember, you don't have to just pick one cloud. You might want to pick another cloud because it has better prices for you, and it costs less to have multiple databases in a, I don't know, HP cloud rather than having them in rack space. So it really depends on the context, and it really depends on your budget and what you need and want to do. And with that, I'm open for questions. Thank you very much.
Any questions?
I'll start bribing. No questions. I was clear enough. You always have a question.
I always have a question, of course.
Just go ahead. I'm gonna sit here.
Like, when is IA infrastructure as a service done? Because you mentioned like this is what's there now. There's DNS, and then you mentioned well in the future maybe metering, orchestration.
Yeah. Well, turns out that this is something I've been saying, and I didn't say today actually. Infrastructure, or let's be more specific, computing and storage, that has to be implicit. Like every time you go to a cloud provider, every time you work on an application, computing is just implicit, because whenever you, like wherever you want to put it, you will need CPU, you'll need RAM, you'll need storage, because you are going to generate data. So it has to be implicit. A cloud provider just selling computing, that's, I'm not gonna say, well, that's lame. And I mean, you need more than that. So when does infrastructure happens? Every time. Whenever you have database as a service, you have infrastructure as well, because it is running in infrastructure. It is running somewhere. Either it's bare metal or virtual machines, there's infrastructure right below it, always. So it has to be implicit.
Sure, so maybe the question is like, where does infrastructure as a service end? Where does platform as a service start? Because like, you could say that message queues, databases are...
Right. Infrastructure as a service ends when you don't need like your physical resources. That's where infrastructure ends. When you're not taking CPU, when you're not asking for CPU, when you launch a new virtual machine, you say, I want to run this virtual machine and I need 2 CPUs and I also need, I don't know, 4 gigs of RAM. That's infrastructure. Once you have your node and you want to install new things into it, that's platform. You don't take care of the infrastructure thing. So when you say to a cloud provider, I want a database, the cloud provider will do the infrastructure part for you. It will run a new instance, and it will take as much RAM as you need, and it will then just install the database for you, and it will give you the URL. That's platform. So whenever you stop requesting infrastructure or hardware resources, then you are moving to the platform thing, to the platform side. But you got to be careful because, for example, in Cinder, which is the blog as a service application we have in OpenStack, it also provides you Ceph as a service, basically. And Ceph is not hardware, but it does have a block device API that you can use. So Cinder hides that for you under a block device API, but it is providing something that is actually not a block device. Like it's actually not a physical hardware, but it is providing you through that API. So you gotta be careful there. Like the limit, like there's some overlap and the limits are so subtle that it is better to just think about the whole thing as a cloud and think about the whole thing like as a single thing that you will consume based on your needs. Other questions? No, I'll shut the fuck up and leave.
Thank you very much.
Thank you all.